A person who never made a mistake, never tried anything. Now we are going to learn about symbols of elements. Chemistry is a unique subject and it has its own language. John Dalton proposed a method of representing the elements by using some symbols. So what are the symbols used by John Dalton to represent the elements? Here it is given. Let's see it. When he used a symbol for an element, he meant a definite quantity of the element that is one atom of that element. We know nowadays such type of symbols which Dalton used, it is not using nowadays. Another scientist, Berzelius, suggested that symbols of elements can be made from one or two letters of the name of the elements. In the beginning, name of the elements were derived from the name of the place from where the element was found for the first time. Example, copper. Copper is derived from, the name copper is derived from Cyprus. And names of some elements were derived from specific colors. For example, the name gold is derived from the English word meaning yellow. We know gold is yellow colored element. Nowadays, IUPAC, International Union of Pure and Applied Chemistry, approves the names of the elements. Many of the symbols are first one or two letters of the name of that element in English. When we are using the symbols, first letter must be capital letter, that means uppercase letter, and if there is second letter, that must be small letter or lowercase letter. It is must. For example, when we are writing the symbol of hydrogen, we have to write capital letter X. And when we write the symbol of aluminium, we have to write A capital letter and L must be small letter. Don't write A and L capital letter. A must be capital letter and L must be small letter. And when we write the symbol of calcium, C must be capital letter and A must be small letter. Symbols of some other elements derived from the first letter and a letter that comes later in their names. For example, zinc. The symbol of zinc is Zn. So N comes later in their name. And the symbol of fluorine, it is Cl. So C is the first letter and L it comes later in their names. Symbols of other elements have been derived from the names of the elements in Greek, Latin or German languages. Many examples we have. Iron, the symbol of iron is Fe. Fe is derived from the Latin word ferrum. And the symbol of sodium, it is Na. It has been derived from the Latin word natrium. And the symbol of potassium is K. It is derived from the Latin word kalium. Here, the symbols of all the important elements have been given here. Let us learn it. Now, let's study about atomic mass. The most remarkable concept of Dalton's atomic theory proposed was atomic mass. We have learned Dalton's atomic theory. In that Dalton's atomic theory, third and fourth point says that atoms of the same element have same mass and chemical properties. And fourth point, it says that atoms of the different element have different mass and atomic properties. So it says about mass. Which mass? It says about the atomic mass. It was the most remarkable concept of Dalton's atomic theory. So according to Dalton, every atom has a definite mass. We know atoms are very small, or it is beyond our imagination. So is it an easy task to find is it an easy task to measure the mass of that atom? It is a very difficult task to measure the mass of an atom. It is a very difficult task. We cannot measure it in kg or gram or milligrams or even small units also. It will not be possible to measure. So as it is a difficult task, we can determine the mass of the atom by using laws of chemical combinations and the compounds formed. Let's take the example of carbon monoxide. Carbon monoxide is formed by combining 3 grams of carbon and 4 grams of oxygen. Experimentally, it has been proved 3 grams of carbon 3 grams of carbon combines with 4 grams of oxygen and carbon monoxide is formed. Or in other ways, we can say that carbon combines with 4/3 times the mass of oxygen. That means one carbon requires 1.3 times the mass of oxygen. So if you are using atomic mass unit, earlier it was written as AMU, but nowadays it is writing as U. AMU, it is atomic mass unit, but nowadays it is writing as U. That means unified mass. So according to that means if you are using AMU, if you are assigning the mass of carbon as 1 AMU, we are assuming that the mass of carbon is 1 AMU. Then what will be the mass of oxygen? Then the mass of oxygen will be 1.3 AMU, because 4/3, that is 1.3 AMU. So here we have the fraction 1.3. It would be more easy instead of this fraction if it is whole number or near to whole number. While searching for various atomic mass units, initially scientists took 1/16 the mass of one atom of naturally occurring oxygen as one atomic mass unit. They selected oxygen. We may ask why they have selected oxygen. They have selected oxygen due to these reasons. The reasons I am saying now. Oxygen reacted with a large number of elements and formed compounds. We know oxygen reacts with a large number of elements and the compounds are formed. Next, this atomic mass gave mass of most of the elements as whole numbers. When we are used oxygen as the basic, then we will get atomic mass of most of the elements as whole numbers. In 1961, carbon-12 atom was taken as the standard reference for measuring atomic mass unit. According to that, one atomic mass unit is exactly equal to 1/12 to the mass of carbon-12 atom. So the relative atomic mass of all the elements were compared with the atomic mass of carbon-12 atom. So let me say an example to clear it. Suppose there was a fruit seller and there is a no standard weight with him. If he want to sell the fruits, how he can sell? And here he is assuming that a watermelon. He is saying that this watermelon contains 12 units. Because till now there is no unit with him. So he is saying that this watermelon contains 12 units. So as he says that this contains 12 units, he can divide the watermelon into 12 equal parts. And each part will be 1 unit, right? Each part will be 1 unit. So whatever the fruits he sells, he can compare it with 1 part of that watermelon. That means here he is using the unit 1 watermelon unit, or we can say that 1 fruit unit mass. 1 fruit unit mass. Because he don't have 1 kg weight. So he can do like this. So same is the case here also. We cannot measure the mass of the atoms. It is clearly, so it is a difficult task. So all the mass of all the atoms, we can compare it with mass of carbon. Because mass of the carbon we assumed as 1, or 1 by 12 to the mass of carbon 12 atom. So now if we want to find out the mass of any of the elements, suppose if we want to find out the mass of hydrogen, we have to compare hydrogen with the mass of 1 by 12 to the mass of carbon 12 atom. Or if you have to find out the mass of oxygen, that oxygen, mass of that oxygen or weight of that oxygen, we have to compare it 1 by 12 to the mass of carbon 12 atom. So now let's define what is relative atomic mass. Relative atomic mass is the average mass of an element compared with the 1 by 12 to the mass of carbon 12 atom. Atomic masses of some important elements have been given here. We have to learn it because that is needed in our coming topics to find out the molecular mass or formula mass. So you have to by heart it. Now we have to know how do atom exist. Atoms of most of the elements do not exist independently. So these atoms together form molecules or ions. So atoms of most of the elements do not exist independently. They will be available in the form of molecules or ions. And these molecules or atoms, they combine in large number to form the matter. Search for knowledge never ends. We will meet in another class with another topic. Thank you.